Good morning, everybody. It's a few minutes until 11 a.m. here on the East Coast, and we will be starting in a few minutes. I think we had quite a few registrants, and so I think we'll give people a few more minutes. Thank you. Looks like there are still a few people trickling in. 11 a.m. here on the East Coast, but let's give folks just a few more minutes and then we'll get started. Thank you. Hello, everyone, and thank you for attending Genetec's Designing Security Center Omnicast Solutions webinar. My name is Howard Rosenthal, and along with my colleague Ethan Becker, we'll be your presenters today. I'm the channel sales engineer for Genetec's Northeast region, and Ethan is the channel sales engineer for Genetec's Central region. How's it going today, Ethan?
Going well. Thanks, Howard, and thank you everyone for joining today.
So as you'll notice, everyone except Ethan and I are on mute, and that will be the case for the remainder of this webinar. However, you guys do have the ability to ask questions. You should see in your GoToWebinar control panel a little questions box. So as I'm speaking, don't hesitate to ask questions through the control panel. Ethan will be monitoring that. If there are any questions that multiple people ask or something that isn't quite clear during the webinar, Ethan will notify me. We'll discuss it with the group. And of course, at the end of our presentation, we'll have a short Q&A. Our course agenda for today will include a quick introduction. This will cover Security Center core system, a little bit about our optional modules. We'll talk about unified platforms and open architecture. Next, we'll talk about system architecture, including the server components, Omnicast specific roles, and distributed versus centralized architecture. And then we'll finish up with a section on designing Omnicast solutions, which includes talking about video fundamentals, calculating bandwidth and storage, creating bills of materials, Genetec licensing packages, and other storage and bandwidth considerations. We'll also go through creating a bill of material, and I'll talk in detail about our license part numbers. So let's get started. So as hopefully many of you know, Security Center, which is Genetec's core platform, is a unified system. So it blends IP video, access control, license plate recognition, and other physical security applications under one intuitive solution, as we say here. We're also open architecture. And what that means is that we support a variety of hardware manufacturers. If I'm not mistaken, in our current version of Security Center, Omnicast, we support approximately 4,300 different makes and models of cameras. And of course, we're very highly scalable. So one thing we'll talk about is the different architectures that you can use, whether centralized or distributed, and how those architectures can be scaled. So as I mentioned before, Security Center is our core platform. Omnicast is the video component of Security Center. Synergist is the access control component of Security Center, and AutoView is the license plate recognition component. Again, these are all part of a single platform, and what turns on the Omnicast or Synergist or AutoView features is simply the licensing. And today's webinar will be focusing solely on Omnicast. However, hopefully you all received the invitation to attend other webinars this week, and Ethan will be presenting on Synergist tomorrow, and we have another presentation on Thursday about AutoView and our StreamVault appliances on Friday. So again, the core system being Security Center, including video access control and license plate recognition. And then we have many add-ons as well. That would include video analytics, integrating with intercom systems or intercoms themselves. We have a web client. We do intrusion panel monitoring. We have a mobile app for those who want to monitor the physical security environment using a mobile phone. And we also have many add-ons to third-party systems. So video walls, We integrate to facial recognition systems, biometric systems, perimeter detection systems, gunshot detection systems, asset management. We also integrate to parking systems and building automation systems. So all of this, again, becomes part of the Security Center platform, one user interface for doing monitoring and investigations, and one user interface for doing configuration. So a quick block diagram of how Security Center is laid out. So we have our core platform, Security Center, and the various feature sets that are enabled via the licensing, whether it's video and access control, video and license plate recognition. Sapelia Communications is our intercom integration. We do integrations to Active Directory. As I mentioned, we support intrusion panel monitoring, perimeter detection, and we also have a visitor management module. On top of that software layer can also be our partner add-ons. Like I said, video walls, asset management, point of sale systems. And then we have what we call our edge devices. Of course, that's the hardware that is being managed by the software components. So cameras, door controllers, SIP devices would include intercoms or SIP servers, LPR cameras, etc. And then as I mentioned, we have the unified security interface. So that would be security desk for doing monitoring and investigation, and config tool for doing configuration. So this is not an exhaustive list of our camera technology partners, but this is just a handful of the partners that we support. Our supported camera manufacturers can be found on our supported device list, which is on our website, www.genetec.com, under the support heading. You can see our supported device list and all the makes and models of all the cameras that we support with our particular versions, with a particular version of Security Center. Next, Module 2. Security Center is a role-based system. And a role in a Security Center system is simply a process running on a server. And depending on which components that have been licensed, different roles will spin up on a server. And basically the roles are primarily managing various hardware. So this list of 9 roles are what we call the default server roles. And these roles spin up automatically based on the licensing. So I'm going to talk about these really quickly. First of all, there's the directory role. The directory role is what client connections, what clients log into. So the directory manages the user connections, it manages the alarms and the audit trails, and it holds the configuration of the whole system in its database. Okay. The archiver is what has command and control of cameras. So we're going to talk about a lot about the archiver during this webinar. It does video recording, it stores events like motion on, motion off. The archiver can do motion detection as well if the cameras don't support them themselves. Something else that's very important in an Omnicast system is a role called the media router. And the media router, as it says, calculates and creates paths between source and destination of both video and audio streams. So basically what that means is if somebody requests video, whether it's live or playback video in a Security Center system, the media router determines the best path through the network that video will travel from the camera to the workstation. If a customer has licensed Synergis access control, then the access manager role will spin up, And the access manager role is responsible for command and control of door controllers and holding access control related events, including access granted, access denied, door forced open, so on and so forth. The LPR manager, similar to the archiver and access manager, is responsible for managing our license plate recognition cameras. Again, that only spins up if AutoView has been licensed. The health monitor is a role that monitors, as it says, system health, and basically sends up alerts if a camera goes offline or a database gets disconnected from its role, or a server goes offline. You will see little red cross symbols, whether they're red or yellow. Red is an error, yellow is a warning in the user interface. The map manager comes with all systems, and the map manager is used for managing the maps that can be imported. If a customer would prefer to use a visual display for monitoring entities, they can import maps and place little icons representing cameras and doors and alarms and so on and so forth, and operators can monitor the environment from a map-based interface. There's also a role that's a default role called the report manager, and the report manager automates report emailing and printing based on schedules. So there's many reports that can be run in a security center system, and if you'd like to create what are called scheduled reports and have them run on a regular basis and sent to a shared drive or sent via email, the report manager is responsible for that. And then last but not least, as far as default roles are considered, is the zone manager. So the zone manager monitors inputs on devices, whether they're camera inputs or door hardware inputs. And if those inputs change state, events can be written to the system, and then actions or alarms triggered off of those. So those are the default roles. As I said before, they spin up automatically based on the licensing for Security Center, and they're also portable. So throughout this training, especially related to the archiver, we'll talk about moving the archiver from a server that is also hosting the directory to a server that, a standalone server. So the archiver is running on a server by itself. So the key server roles per solution, again, for video, it's directory, archiver, media router are the important roles. For access control, directory and access manager, and LPR, directory, LPR manager, and archiver. But again, this is an Omnicast related webinar, so we're primarily going to be talking about the directory, the archiver, and the media router. When we talk about security center architectures, there's two basic types of architectures in a Genetec environment. One we call distributed, and the other is called centralized. And this gets back to the notion of the roles being portable. So in distributed architecture, we say that there's a single directory role. So the directory role, which manages client connections and holds the configuration database, we consider kind of to be the main role. It's not that if the directory goes offline, that the whole system shuts down. That's not actually true. If the directory goes offline, user connections get disconnected because the directory is what validates user credentials, but other parts of the system can remain functional. So for instance, an archiver on a standalone server, as depicted in this diagram, can still record video and still receive events from cameras. It's just that no one can view that video or run reports on those events, because if the directory is offline, no one can log in. So in distributed architecture, you see we have a directory server And the media router roles running on that same server, which is very common because not only do you have client connections connecting to the directory to log in, but you have clients requesting video from the media router. So because they're both roles take requests from clients, it's kind of a best practice to leave them on the same server. But then we have archiver roles. That's these symbols on the two servers next to the directory. Archiver roles on separate servers. Okay, so the archiver roles at the head end are managing the head end cameras, but then we have remote systems as well connected through the network. And those remote sites, or I'm sorry, I shouldn't say remote system, they're actually remote sites. And those remote sites are just running the archivers that are managing the local cameras. So in a distributed architecture, the clients or the operators all have to connect to the directory at the head end, okay? And all the video, however, is recorded locally. So in this scenario, if the network gets disconnected between the head end and the remote sites, the clients that are connecting to the directory can no longer monitor live or recorded video or run reports, but the archivers at these remote sites, as long as they remain up and running, they'll continue to record their cameras, okay? In the next architecture scenario, we have what's called centralized architecture or federation. So as it says here, centralized architecture is typically used for organizations with a large number of sites that are geographically separated. And in this architecture, each site is its own security center system. And what defines a security center system is the existence of a directory. So for instance, in the previous slide, you can see I have the directory. This is the icon, the globe at the head end, but I only have archivers distributed at the remote sites. In my centralized architecture or federation architecture, I have a directory at the head end, a directory at the remote, and directories at both remote sites, and those remote sites are systems in and of themselves. What allows you to scale with this architecture is something called the federation role. And we have a federation role at the head end, and the federation role has login credentials for the remote sites. They connect to those remote sites, and somebody who's monitoring or logged into the directory at the head end can view video and run reports, not only for head end cameras, but also for the remote site cameras as well. So to somebody logging into the head end, all these sites together look like a single system. Now, in the scenario where the network gets disconnected between the head end of the remote sites, all this means is that those logged into the remote site or the head end directory can no longer view video or run reports at the remote sites, but because the remote sites are systems in and of themselves, you can still log into the remote sites because they have directories, and then you can do your monitoring and investigation easily. Next, system design, module 3. Before we get into this, Ethan, was there any questions in particular that you thought we might need to address with the group? Or are we okay?
So far, we're good. No questions yet.
Okay, great. I hope that just means everybody's understanding.
I think you're doing a great job.
Okay, thank you very much. Appreciate that. So now let's talk about system design. And first we'll talk about IP fundamentals. So, you know, a lot of terminology thrown around: NVR, DVR, RTSP, RTP, SAS, SATA, unicast, multicast, G64, digital signature, etc. So many of these we'll be talking about during this class because some of these greatly impact our Genetec Security Center system design. So one thing to talk about as a basis when we're talking about system design is video format, because it's very important in calculating your storage and bandwidth. So just a quick tutorial on video compression. If we have a camera viewing this scene and a car goes across the scene and the camera is encoding video in MJPEG, motion JPEG, every single snapshot or every single frame of video is the whole picture or a whole snapshot of what's in the scene. So we call that a keyframe or an iframe. Okay. If, however, we want to use a compressed format, MPEG-4, H.264, and now for some cameras, H.265, we have the same scene. Car goes across the road. Now we have a single frame video that's a complete snapshot, and then subsequent frames are only the changes that happen. And then we have another keyframe or iframe to close that off. So a couple things to mention about video compression. Compressed video, as you can see, it's not scrunched, so to speak. It's just missing some data. And this data is then decoded, so to speak, by the workstations. So MPEG-4, H.264, H.265 streams require much less throughput and obviously much less storage, because as you can see from this slide, there's data missing, okay? So again, if throughput and storage is an issue, compressed format is probably the way to go, because the difference between MJPEG, let's say, encoding and H.264 in terms of storage and throughput can be very significant. But what you have to watch out for on the front end or on the client workstation is that the client workstation has the proper specifications to be able to decode those H.264 streams, because when they receive the H.264 streams, a workstation has to make sense of this missing data, so to speak. So in Security Center systems, our client workstation software security desk supports graphic processing units for doing the decoding. We support NVIDIA cards. So good idea if you want to use compressed format video that you have discrete graphics cards. That's generally our recommendation. If not, it's the CPU that does the decoding, and that can be very resource intensive. So what kind of format the video is encoded in, or the compression format, is very important for doing your storage and bandwidth calculations, as I mentioned. And people always ask, does Genetec have a storage and bandwidth calculator? And the answer is no, we do not have a storage and bandwidth calculator. To get the most accurate storage and bandwidth calculations, it's recommended that you use the storage and bandwidth calculator supplied by the camera manufacturer. So here's just a couple screenshots of a few camera manufacturers' storage and throughput calculators. We have Bosch, we have Axis, we have Ericont, and I've also chosen BCD video storage calculator. So I'm not sure if many of you know, but Genetec has a line of server appliances. They are called StreamVault. They are manufactured by BCD Video. And when a bill of materials is getting put together, if we haven't been provided the storage and throughput calculators by our integrator, the storage and throughput calculations by our integrator partners, in general, we will just use the BCD video storage calculation to size the servers. Something else to keep in mind is the ability of cameras to support multi-streaming. So many cameras today support multi-streaming or the ability to encode multiple streams of video. So some cameras may support encoding 3 video streams, some may support encoding 4, some may support encoding 6. And Genetec supports multi-streaming in that if a customer wants to have one resolution and frame rate being recorded, but a completely different resolution and frame rate for live video, and another one for going to mobile phones, we support that ability as long as the camera does. So, here in the slide, we have an example, live stream megapixel 30 frames per second, but we're recording at 4SIF 15 frames per second. And we have video going to mobile phones at VGA and 10 frames per second. So if the camera themselves support that, we support that in the configuration. Transport protocols. So this is something that we're going to talk a lot about when we talk about server sizing. And transport protocols that they generally speak of regarding video include unicast. And unicast is a one-to-one relationship. Think of it as making a phone call to an individual. There's also multicast. So multicast is one to many. You can think of that as a conference bridge, kind of like what we're on right now. And then there's broadcast. So broadcast is one to all, and you can think of that as a PA announcement. Multicast and unicast is something that can be configured in a security center system. The default happens to be multicast, and I'll go more into that in the next couple slides. Broadcast is generally something that you don't want to happen. You don't want video streams to be sent to every network endpoint because that could, of course, cause your network to crash. So let's talk about an environment where we have unicast. So unicast is the transport protocol across the network for a video stream. We're going to talk about many scenarios now. We have a camera, we have a switch, we have a server running the archiver role. So the camera is streaming video at 2 megabits per second. It's connected to a switch. Those 2 megabits per second are sent down to the archiver for recording. And we've got multiple client workstations on the network that want to view video. So the archiver is going to accept the video stream from the camera at 2 megabits per second. And we have 4 client workstations, each wanting to view live video from this camera. This is configured in multicast. The network is set to multicast, which I said was a one-to-one relationship. So for every video request, the archiver needs to send up a stream of video. So as you can see from this example, we've got 2 megabits per second coming down, being recorded, but then the archiver and a process called the redirector are redirecting video up based on the request from the client workstations. So we have 8 megabits per second, 2 megabits coming down, 8 megabits per second coming up. Okay, not a lot of bandwidth, 10 megabits per second total throughput on the archiver, but this is just a simple example, and we'll get into some more complex examples in a minute. Now, let's look at a scenario where we have multicast configured on the network. So we have a camera, again, streaming video at 2 megabits per second. 2 megabit per second stream goes down to the archiver for recording. And then, because the network is set to do the multicast streaming protocol and the switches support it, the archiver is going to send up a single multicast stream that's then going to be distributed by the switches. So As I said before, in a security center system, unicast streaming protocol is set by default. So this first scenario here is the default scenario. However, if a customer wants to use multicast, we completely support that, but two things have to happen. First of all, you have to confirm that your switching hardware support it. And what's required is a protocol called IGMP, Internet Group Management Protocol. So IGMP snooping and querying has to be supported on the hardware. And then somebody has to be capable of configuring that on the network. In a security center system, it's as simple as setting a switch to say, I want video to stream in multicast, but there's a lot that has to be done on the back end to get that to work properly. But if, again, a customer has the capability and the hardware, you can see that we have a significant reduction in the amount of throughput or load on the archiver. So we went from 2 megabits down, 8 megabits up for a total of 10 megabits per second to 2 megabits up, 2 megabits down for a total of 4. And we're going to get into, this isn't a very realistic scenario. We'll get into some more realistic scenarios shortly, but I hope that makes sense. One other example, again, this is multicast by archiver. So this is a scenario where the camera does not support the ability to send a multicast stream. So some cameras do support that ability, some cameras do not support that ability. If the network is configured for multicast, the archiver is, or the security center is set to stream in multicast. If the camera doesn't send the multicast stream to the switches, the archiver will. And then here, we say multicast everywhere. Basically, that means the camera will support multicast, and we have the camera sending out a multicast stream. The archiver still needs that stream because it's set to record, so it's 2 megabits per second comes down. And then the archiver does not need to send any video up because the camera supports the ability to send a multicast stream, and then the client workstations just get that stream distributed from the switches. Okay. So those were some examples, and we'll get into several others shortly. But let's talk about server design. So again, just want to make this point, before doing any server designs for any security center solution, it is strongly recommended that you read the Security Center System Requirements Guide. Okay. The system requirements document includes server design information for Omnicast, Synergist, AutoView, mobile server, web client, our analytics, and virtualization for those who want to use a supported virtualization product. It also includes workstation related information and software such as SQLs and Windows requirements. If you're asking where can I get the system requirements document, and I'm going to post it in the handout section in just a minute. You can get that at our tech.doc hub and just do a search for system requirements. So the tech.doc hub can be accessed at portal.genetec.com. If you don't have access to the Genetec portal, at portal.genetec.com, you can click on the request access, complete the form, and someone will get back to you about with a username and a temporary password. So as we said before, the system requirements guide lists server related information and workstation related information. And I just want to show you what I'm going to do is I'm going to post a document, this document in the handouts. So just give me a second. And we have some documents to share here, and I'm going to start with this one. And it should be uploaded, and hopefully you all can see that. So I want to kind of poke around the system requirements document really quickly. If you want to follow along through that document, you can, but it's not necessary. So let me pull this document up really quickly. Hopefully everyone can still see that. Ethan, just as a check, you can see the,
Yep, we can see your screen yet.
Okay, great, thank you.
Yep.
So let me make this a little bigger. So here's the system requirements, the current system requirements document. And I'm just going to scroll through here really quickly and touch on some key points. So first of all, we have client workstation requirements. And basically these requirements are client workstation specifications. So we break workstations into minimum, recommended, and high performance. And you can see minimum Intel Core 2 X6800, about 3 gigahertz, 2 gig of RAM, 32-bit operating system. Recommended 4th generation Intel Core i7, 8 gig of RAM, 64-bit operating system, and an NVIDIA card for decoding. And then high performance would be similar specifications with more RAM and a high-end video card. Why is this important? Because on the next page, we say the maximum number of cameras viewed per client type. So client type is minimum, recommended, and high performance, right? Which we have on the left-hand column here. And based on the client type and the resolution, frame rate, and compression format of the video, that will determine how many video streams can be viewed simultaneously on a client workstation. So for instance, if we, in this table, we see the videos in H.264 format, it's streaming at 30 frames per second. If we take the VGA column, 640 by 480, the minimum spec workstation can only stream 6 simultaneous video streams. However, the recommended can support 47 and high performance 58. And the biggest difference between the minimum and the others, of course, is the existence of the GPU, the NVIDIA graphics card. So this takes a big load off the CPU, and therefore you can stream more video. And here on the far right, you can see full HD 1920 by 1080 against H.264, 30 frames per second. A minimum recommended or minimum spec workstation can only support a single HD camera at 30 frames per second, full HD. Recommended can support 11 and high performance 26. So that's just an FYI, something to keep in mind. If you're speccing out client workstations, you need to know how much video each client will be viewing simultaneously. As I scroll down, we start getting into server requirements, and we see something similar here with minimum recommended up to 300 megabits per second, above 300 megabits per second up to 500 megabits per second, and then what we consider high performance. So for you all who may be familiar with past versions of Security Center, this section above 300 megabits per second up to 500 megabits per second, if you had ever looked at the system requirements document for previous versions, we didn't have that. This is something new with Security Center 5.8. So again, minimum Intel Core 2 Duo E6850, 3 gigahertz, about 4 gig of RAM, 100 megabit to gigabit Ethernet connection. Recommended will support up to 300 megabits per second throughput. It's a Xeon processor, 64 gigs of RAM, gigabit Ethernet, and 80 gigabytes SATA 2. Between 300 and 500, we have something that is similar, except we have dedicated RAID for that. similar to the 300 megabits per second, sorry. And then what we consider to be high performance is our StreamVault rack mount appliances. So the StreamVault appliances are the only servers that we certify you can get over 500 megabits per second throughput. So we have a number of series, StreamVault 2000 series, 4000 series, 7000 series. They start at a single server starting from 300 cameras or 500 megabits per second up to 1,000 cameras and 2,000 megabits per second. So if you're not familiar with our StreamVault rack mount appliances, please try to attend the StreamVault webinar, and that's taking place on Friday at the same time as this one from 11 to 1. Okay. So this information again is important, minimum recommended high performance, because the specification of this server and what security center components are running on it is going to determine how many cameras and how much throughput it can support. So if we have, the way you read this table, maximum number of cameras and readers per server type, because we do it for both cameras and door readers. If you have the directory and the archiver role running on a server, the single server, the minimum spec server can handle about 50 cameras or 50 megabits per second. A recommended server can handle about 100 cameras or 200 megabits per second. However, if you take the archiver and put it on a server by itself, that is the standalone archiver, the minimum server spec can support 75 cameras or 75 megabits per second, and the recommended 300 cameras or 500 megabits per second, depending on which spec you're using. Okay, and then we have directory and access manager and standalone access manager. That's for access control. But what we're most concerned with in this class is these top two lines. Okay, and in the subsequent examples in this webinar, we're going to talk about servers that are spec'd out to only support 300 megabits per second, and we'll go through many examples of that. Okay, I hope that makes sense. And again, very important to review the system requirements document that can be found on the Genetec portal. Okay. So we talked a little bit about unicast and multicast, and we did an example which wasn't really that realistic. I don't know how many single camera systems there are out there. Hopefully, it gave you an understanding of how that works, but let's look at the differences in throughput when we have different transport protocols in larger systems. So our other example was a single camera. Now let's say we have 100 cameras in the environment. So we have a camera connected to a switch, and we have our archiver server managing these cameras. And we have 100 streams, 100 cameras, each streaming at 2 megabits per second. So this is a total of 200 megabits per second from coming into the archiver for recording. Again, if we have unicast, we have 4 workstations. Each of these workstations, let's say, is requesting 16 video streams, okay? So what's gonna happen is the archiver is gonna receive 100 camera streams for a total of 200 megabits per second for recording, and then to support the workstations, the archiver is going to send up 64 streams. So we have 4 workstations, each requesting 16 cameras. That's 4 times 16 is 64. 64 times 2, that's 128 megabits per second. So we have 16 streams going up to the workstation connected to the same switch. And then we have 48 streams at 96 megabits per second going across the network to fulfill the request of the other 3 workstations. okay? So our total throughput in this case is 200 megabits per second coming down for recording and 128 megabits per second going up to support live viewing. This is 328 megabits per second total. So if we had the first recommended spec server, which only supports up to 300 megabits per second, we're over our limit, right? Because we have 328 megabits per second. That's why this is in red. So we need to watch out for that. And of course, we wouldn't want to go to the full 300 megabits per second or the full 500 or the full 2000. We want to leave some headroom because throughput calculations are not always exact. So you want to leave headroom if there's something in the environment that causes the video streams to be larger than you would imagine. Okay. Next, we'll talk about unicast everywhere, as in the previous example, but we're going to add a component to another server called a redirector. So in Genetec video architecture, there is the media router role that takes requests from the client workstations for video, the archiver role, which manages the cameras themselves and does the recording. And there's something called the redirector process that runs on every server that hosts the archiver role, but can also be added to other servers that basically takes its direction from the media router. So the media router is getting requests for video and determining the best path through the network that the video should travel, but the media router doesn't push video through the network. It's the redirector that pushes the video through the network. So in this scenario, if we add a redirector to a server, which can be easily done in a security center environment, and we have 100 cameras streaming at 2 megabits per second for a total of 200 megabits per second. We have 100 streams coming down to be recorded, 200 megabits per second. We have our client workstations again requesting 16 video streams each. And what happens with the additional redirector is it takes some of the load off of the archiver. So what happens is the archiver will send the video 16 streams to the client workstation that's connected to the same switch that it's connected to, 16 streams for a total of 32 megabits per second, and it will send 32 streams across to the second switch that is connected to the redirector, and the redirector will then be responsible for streaming the video, the 16 video streams per client workstation to those workstations that are connected to the switch that it's connected to. So you can see in this scenario, if we add a redirector, we've taken a significant load off the archiver, and now we have 200 megabits per second down and 64 megabits per second up for 264 megabits per second. So we're below that 300 megabit per second threshold, which is why the box is green. Okay. So again, we have to watch out on our throughput for archivers because they do have limits. Now let's look at unicast versus multicast. So we already did unicast versus multicast by archiver. This is by archiver because let's say the camera doesn't support the ability to send a multicast stream. So from our first example, we have 100 cameras streaming at 200 megabits per second. So 200 megabits per second coming down for recording. And then we have 64 streams at 128 megabits per second going up to support the requests for the 4 client workstations. So we already know that that was 200 megabits per second down and 120 megabits per second up for 328, which is over our limit based on the server spec that we have. So now let's look at the same request, but we use multicast transport. So in this case, because it's the switches that are doing the distribution of the video stream in multicast, because they support the IGMP protocol, what happens is the archiver will then set up 32 streams at 2 megabits per second. That's 64 megabits per second. Now we're assuming that only 32 different cameras are being requested by these 4 workstations. So that's where we get the number 32. So 32 streams for a total of 64 megabits per second are being sent up by the archiver. And then the cameras are responsible for, or I'm sorry, the switches are responsible for distributing the video to the workstations. So that's significantly less again than, whoops, went the wrong way, than our 328 megabits per second. Now we have 264 megabits per second if we do multicast by archive. And the last scenario is going to be multicast by archiver versus multicast everywhere. So we just showed multicast by archiver, 32 streams at 64 megabits per second going up and 200 megabits per second going down, right? For a total of 264 megabits total throughput in that archiver. And now let's see what the load on the archiver would be if the camera supported the ability to send a multicast stream. So now we have the 200 megabits per second coming down because we're recording the video, so that's always going to be the case. But we have no video being redirected by the archiver and redirector because the camera is sending a multicast stream that's then being distributed by the switches. Okay, so that's a significant reduction of the load on the archiver. A lot of people ask, why is Genetec pushing multicast? And it's not necessarily that we're pushing multicast. We just want to make our partners and our customers aware that we support multicast streaming within a security center environment. And again, if they have the switches that support it through IGMP and the staff that can configure those switches, then you do have a savings not only in terms of network utilization, but also in the load of the archiver. So now let's talk about bills of material. So the main system deliverable, system design deliverable is a bill of material. And in order to have bills of material, you need the licensing. So that includes the security center software packages. You need to know the number of servers, okay, based on the number of sites, how many cameras, total bandwidth. And of course, you also need to know how much storage you need on those servers. So let's talk about licensing really quick. And right here, this diagram comes from the Security Center 5.9 ordering guide. And I'm going to post this to the handouts as well. But I just want to go over this diagram really quickly. This diagram lists the Security Center packages. We have 3 on-premise packages that include standard, professional, and enterprise. And basically, those packages are based on the number of cameras, which you can see at the bottom, the number of archivers, which you can see on the left-hand side, and the number of client workstations, which you can see on the right-hand side. So the standard package will support up to 50 cameras, a single archiver, and up to 5 client connections. In addition, we have the base functionality, so alarm management, plan manager, which is the mapping basic, email support, media router, audio, camera sequences, support for virtualization and video encryption, and there's some optional functions as well. So mobile phone, video wall plugins, intercom management as well. If you have over 50 cameras or need to go to multiple archivers, then you need to go to the professional package. So professionals package supports up to 250 cameras, up to 10 client connections, as we see on the right-hand side. You can have multiple servers, remote security desk, camera blocking, and then all these other features. Privacy protector, intrusion detector, plan manager standard, other plugins, threat levels. Okay. Then if we need to go above 250 cameras or we need to go above 10 client connections, then you could start getting into the enterprise space. And that's basically unrestricted scalability, and then support for features like federation, which I talked about, and failover. Something to mention though, if for instance, you had a system with 40 cameras, but you wanted to have an integration to Active Directory to import users and or cardholders from Windows Active Directory, since Active Directory is only supported in the professional package, even though you have below 50 cameras, you have to go to professional because that's what supports Active Directory, or that's the package that you need to support Active Directory. Okay. And I want to, again, I'm going to add the ordering guide to the handouts real quickly. And here's the 5.9 ordering guide. And you all should have that in the handouts right now. And I just want to open this up really quickly. So here's the Security Center ordering guide. And, oh, sorry, I'm just scrolling through and I want to show you where that package diagram is. So I'm just scrolling through. There's an explanation of the part numbers, and here is a smaller version, maybe I can make that a little bigger, of the Omnicast packages, standard, professional, enterprise. Okay. We also have the same package selection for Synergis, which is the access control components of Security Center. This is something that Ethan will be talking about tomorrow in the Synergis webinar. This document, by the way, also lists all the part numbers. So it talks about the base package, so GSC-base-5.x, currently the X would be 5.9, and what's included. So the basic package includes the directory, 5 client connections, plan manager basic, alarm management, zone monitoring, etc. Okay, then here's a description of what those features are. Then it talks about additional part numbers. So the base package includes 5 client connections, but if you need more client connections than that, then in the bill of materials, you would need to add GSC-1U for a client connection times the number of client connections that you want, or GSC-1U-STU, which is a site license for client connections. And if I'm not mistaken, I think the break-even point in terms of cost between the site license and the individual client connections is about 40. So if you need 40 client connections, it's from a cost perspective better to go with the site license. Then we have the part numbers for mobile connections using the mobile app, things like threat levels, integrating to Active Directory. So all the part numbers are listed in this document and a description of what each of them are. Each of the parts are as well. So this is very useful. Something to keep on hand, and also something that you can get from the portal. Okay. Ethan, were there any questions that you thought we should address, or are we okay?
We're looking good on questions so far. Thanks, Howard.
Okay. Okay, so let's talk about a basic bill of material for systems less than 50 cameras. So you always need that base part, GSC-base-5 dot whatever the version is. So if it's a new system, it would be 5.9. We're talking about Omnicast systems, of course. So the next part number would be GSC-OM for Omnicast-S, and S stands for standard. So we have less than 50 cameras. So it would be the standard package. And then, of course, you need the camera connections, which is GSC-OM-S-1C times the number of cameras that you want. So 1C is the IP camera part. And again, on the slide, GSC-base-5X, this tells you what's included. And then GSC-OM-S, this tells you what's included with standard. And this comes, again, straight from the ordering guide, which is very useful. Okay. We have some other camera-related parts, and I actually probably need to update this slide, but as I said, the GSC-OM-S-1C is the part number for an IP video unit. GSC-OM-S-1PAC is for analog camera connections. So we support connecting IP encoders to Security Center that then have analog connections to cameras. We have something called video import profile. So GSC-OM-S-1VIP video import profile allows you to bring in video from a body wearable camera, for instance, and have the archiver index it so that you can run investigations in Security Center on video that was imported to the system. And then even though this says GSC-OM-S-1RC restricted camera licenses, we don't have those licenses anymore as of a couple of weeks ago. There were some manufacturers' cameras that were restricted on a Genetec system, but supported through this RC license, and we no longer support those. There are other devices that can be added to the system. They're actually added as cameras, but they don't use a license. So you might be familiar with IP connected speakers. Axis makes one, the C3003, or input network attached input output devices like the Axis P8221. They're added in the system as video units, but don't consume a license. Okay. And as I said before, the supported devices list can be found on the Genetec website under support. So let's talk about some additional bill of material examples. So we're going to use the Security Center ordering guide to create a bill of material for the following scenario. So you all are on mute. This isn't interactive, but maybe you want to take a look at the packages diagram on in the Security Center ordering guide. That will help you answer these questions, and I'll just go through them here. So let's say we have a system that requires 15 cameras, 7 security desk users, and 4 web clients. So which package do we need for that? That would be Omnicast Professional, because we have between 5 and 10 users. So standard supports 5, professional supports up to 10, and enterprise is unlimited. Now you may ask yourselves, well, 7 security desk users and 4 web clients, that's 11. But in actuality, a single client connection in a Security Center system includes 1 connection for security desk and a connection for a web client. Okay? So we, in actuality, haven't gone over our 10 user limit for Omnicast Professional. Next scenario, 55 cameras, 2 security desk users, 4 web clients, 5 mobile clients. Again, this has to be an Omnicast Professional package because we're over 50 cameras that are supported in standard. 2 security desk users and 4 web clients are included in the base package. And then the 5 mobile clients need to be purchased separately using the part number. So mobile clients can be connected, licensed in standard professional enterprise, but you need the part number. Another scenario, 200 cameras and 200 security desk users. So even though we're below the 250 camera count that's supported in a professional package, because we're over the 10 user count requirement, this has to be an Omnicast Enterprise package. And again, as I mentioned before, site license for users is recommended, the cost equivalent to 40 users. So just use the site license part, and that's basically unlimited users. So Omnicast Enterprise with an unlimited user site license. Next scenario, 25 cameras, 2 security desk users, and failover for all cameras. So we see the 25 cameras again is below the Omnicast standard limit, but failover is only supported in enterprise packages. So this system needs an enterprise license, and of course the users are included with the base package. Next, 15 cameras. We want to integrate to Active Directory so that we can synchronize users from Active Directory and our cardholders, which makes managing in users and cardholders quite simple because you have one location to add or disable users and cardholders. So in our Active Directory integration, if someone is added to Active Directory or removed from Active Directory, they will be added or removed from Security Center, okay? So 15 cameras, Active Directory integration, 1 mobile client. System needs to be federated into a central site. So again, federation from our example before, we had a head end and some remote sites, and this system would be considered a remote site. So it's federated into a head end. 15 cameras, Active Directory, 1 mobile client, system needs to be federated. This would be Omnicast Professional. So Omnicast Professional is required for Active Directory, and the mobile user needs a license. System being federated does not affect the license. So a lot of people think that when you're doing federation from a head end to a remote site, that you need a federation license on both the head end and the remote site, but that's not true. We talk about the site that's federating, that would be the head end, and the site that's federated would be the remote site. The remote sites never need the license. It's just the head end that's federating to the remote site. So the fact that this system needs to be federated has no impact on licensing, but it needs to be professional to support Active Directory integration. Next is same as above, but needs to be federated 5 times into 5 different locations. So again, it's the federated system, not the federating system. There are 5 head ends, so to speak, that want to connect to it to view its cameras and events. And again, it's the same as above because there's no change in licensing no matter how many times a system is federated, right? It's the federated system, so no additional licensing is required. Next, we have a system with no cameras, 7 users. The system is federating 3 sites, all running Security Center, recording 15 cameras each, okay? So in this case, it is the federating site. It's running the directory. It's got the federation roles connecting to 3 sites, and 7 users are logging into it. And in this case, this would have to be an Omnicast Enterprise package. And an Omnicast Enterprise simply because you need Enterprise to support Federation, and then you need the part number for 3 federations. Okay, so I hope those scenarios make sense. So again, we already talked about this. The required rules for Federation, or I'm sorry, for Omnicast are the directory, the archiver, and the media router. And depending on various factors, including server specs, these roles could run on a single server or need to be split across multiple servers, as we described in the distributed architecture example. Okay. So I'm not going to go through this again. I think you guys, hopefully you guys understood the server specification from the system requirements doc, and the fact that not only do the server specifications determine how many cameras and how much throughput are supported, but also what's running on the server. So is it going to be a standalone archiver, or is the archiver going to be running on both, on a server also hosting the directory? So here's an example where we have 50 cameras streaming at 2 megabits per second for a total of 200 megabits per second. I'm sorry, 100 megabits per second. And in this particular case, we're below the 100 camera or 200 megabit per second limit for having the directory and archiver on a single server. So all of this it's a single server environment. Directory and media router, and archiver manages all 50 cameras. Okay. And this is using the recommended specifications from the system requirements doc. Here's another example. Directory server, we have 120 cameras at 240 megabits per second, so each streaming 2 megabits per second. And what we've done is we've split the camera load. So we have one server hosting the directory media router and an archiver, okay? And that will support less than the 100 cameras and 200 megabits per second. And then the standalone archiver will take the additional load of the additional cameras. Okay, this is solution 1 in this scenario. Or solution 2 could be that we have the directory and the media router on a single server and the archiver supporting all the cameras, the standalone archiver. Because again, we have 120 cameras at 240 megabits per second, and we were going to use those recommended specs for 300 megabits per second. We're below that number, so a single archiver should be able to handle this. So you would need 2 servers in the environment, just as in the previous example, but you don't have an archiver running on the directory and media router server. So let's talk about the archiver server itself. So what do you need to know to spec out your archivers? Of course, you need to know the number of cameras, your total bandwidth and storage required. So that's something that will have to be calculated through the storage and bandwidth calculators. Any project requirements for servers, such as virtual machines, and supporting those as part of the system requirements, or what you need to know to support virtual machines is part of the system requirements document as well. And you get this information from the end user or RFP, and of course, refer to Security Center system requirements for all the information. So, important questions: how many cameras? What is their codec? Is it H.264? Is it H.265? Is it MJPEG? This is something that will have to be plugged into the storage and throughput calculators, as is the frame rate. Is it recording on motion or recording continuously? This is also something that is generally a part of storage and throughput calculations. If it's recording on motion, what percentage of the day are cameras estimated to record? So 50% for 12 or 12 hours a day. Something that is also part of the storage and throughput calculators. How many days to keep video? Of course, your retention period is going to determine the size of your disks. Uh, are they direct attached? Are your disks, is it a NAS? Is it a SAN? Do you require a RAID to protect the data? Do you want to use SATA or SAS? Something else that you need to keep in mind is the number of live and playback streams, right? So we can use the breakdown of cameras and their codec and frame rate and so on and so forth for calculating the recording throughput, but then the number of live and playback streams will determine the redirection throughput. And we saw that those numbers, the recording throughput and streaming video for live and playbacks, distributing streams for live and playback needs to be combined with the storage figure so that you know total throughput for the archivers. Is multicast going to be enabled, or is this purely a unicast environment? And we know that with multicast we can significantly reduce not only the load on the archiver but the load on the network as well. Is digital signature required? So digital signature is a security center feature that allows you to validate. It's an algorithm that runs that allows you to validate that exported video hasn't been tampered with. If it needs to go, if video needs to be submitted for evidence in the courts. And then is encryption required? Because there are also requirements for encrypting video that's also in the system requirements document. Okay. Also, network information. Again, do you support multicast? What are your network interfaces? 100 megabit, gigabit, 10 gigabit? Is there other traffic on the same network? Are there VPNs, firewalls, VLANs, network address translation? All things that you need to take into consideration when designing a Genetec system. Some other considerations, and again, this is part of the system requirements doc. Multiple archiver roles can be recreated on the same server, up to 5 roles, and that's one of the ways in which we get additional throughput on our StreamVault servers. Each archiver role requires its own SQL database and disk partition. That's part of the setup procedure. Partition size should remain around 20 terabytes. Archiver role does support connecting to a remote SQL instance, but it's not recommended because if there's any latency between the connection of the role and the database, that could cause problems and potential loss for video recordings. Also, you need to keep in mind Security Center comes with SQL Express, which has a database size limit of 10 gigabytes. If you need more than that, then you need to go to SQL Standard or above. But something to keep in mind is that the actual video files are never stored in the database. So Security Center recorded video files are stored on disk, and the pointer to where on the disk that those files are stored is what's in the database. So the files themselves are not in the database. Okay, and here's just a screenshot showing you we have 3 archivers, and each of them has their own database: archiver 1, archiver 2, or archiver 1, and archiver 2, and then they each are writing to their own disks. Okay, something that's very important. Additional consideration for archiver server specs. So again, this is in the system requirements doc. Software-based motion detection can reduce the maximum capacity by up to 50%. So for cameras, if you want to do motion detection, the archiver can do that motion detection if the camera doesn't support it, but it's very resource intensive. So if you turn on archiver-based motion detection, it could reduce the number of cameras that the archiver can support by as much as 50%. As I mentioned, digital signature is what's turned on if you think that you're going, a judge or a lawyer will request validation that video hasn't been tampered with if it's submitted as evidence. That also can reduce the maximum capacity of an archiver. And then last but not least, virtual machines, because there's an overhead with the hypervisor on a server, virtual machines with the exact same specs as a physical counterpart, has about 20% less capacity. So if we're talking about a standalone server that supports 300 cameras, if it was, and that's on bare metal server, if it was a virtual machine, it would only support 240, which is about a 20% reduction. So again, this is all in the system requirements document. It's all documented for you to review. So recommendations for server designs for COTS stands for commercial off-the-shelf server. So here's the published numbers on the left-hand side that we saw in the system requirements doc. And if you're designing, like I said, you want to leave some headroom. So I think some of these numbers may be a little extreme. So all-in-one is archiver, directory, and media router on the same server. Published is 200 megabits per second. We say maybe only designed for 100 megabits per second. That might be a little low, but I think the point here is you need to leave headroom. You know, don't max out your server throughput, because inevitably there could be changes in the scene and more data is going through the network you anticipated. So you don't want to max out those archivers. Again, standalone archiver, 300 cameras, or design consideration of 150 megabits per second. Again, that might be a little low, but just try to leave headroom. And don't forget to take into consideration if you're using server-based motion detection, digital signatures, or virtualizations, because that'll reduce these numbers as well. So storage considerations. Security Center does not manage hard drives or file systems. So any storage system attached and recognized windows can be written to by the archiver, okay? Archiving on the OS partition is definitely not recommended. The C drive, there's a lot going on in the C drive with the operating system, so it's best not to write video to the C drive. Server running multiple archiver roles, I already said, requires its own disk partition. Estimate storage using a bandwidth calculator from the camera vendor is where you're going to get the most accurate reading, okay? So generally for the camera vendor storage and throughput calculators, you'll need the camera model, the resolution, frame rate, recording mode, motion, retention period, and of course, something that isn't here is the codec or the compression format, okay? And if you want to get, actually, this should say 500 megabits per second throughput if you want a single server that can support more than that, then use our StreamVault appliances. And I already mentioned workstation design. So the most important thing is understanding how many simultaneous video streams will be requested by client workstations, and Genetec client applications support NVIDIA cards, okay? So if you're streaming a lot of video, especially H.264 back to client workstations, you want to make sure those have NVIDIA cards. And something I haven't mentioned yet, but in addition to the StreamVault rack mount server appliances, we also have StreamVault workstations as well. And then if you have an off-the-shelf server, you just want to make sure that you choose an NVIDIA card with a compute capability of 5.0 or higher, and those are listed on the NVIDIA website. So let's talk about a couple more scenarios as we start to wrap this up. So scenario one, we have 50 cameras recording at 720p, that's HD, 7 frames per second. We're going to assume that this is about 1 megabit per second per camera, recording continuously for 30 days. And these are off-the-shelf servers. So how many servers do we need? Doing the calculation, we'll need a single server. And with these calculations, it requires about 16 terabytes of storage. So the bill of materials would be, and what we don't have here is the base part number, remember we need that, GSC-base-5.9. 50 cameras, so this fits into the standard package, GSC-OM-S, and 50 times GSC-OM-S-1C for IP cameras, and the server needs to have storage to support about 16 terabytes. Scenario number 2, we have 100 cameras. Of course, we need to know the bandwidth. The network type is a unicast or multicast, but unless we're told differently, in providing quotes, we're always going to assume unicast. And we're going to assume that we have 100 cameras streaming at 300 megabits per second. So how many servers do we need? 2 servers of recommended specs. So if we have 100 cameras at 300 megabits per second, that's topping out that basic recommended specification, which is 300 megabits per second. So we would have a directory and a media router server, and then we have an archiver standalone server. Actually, we're going to have a directory, media router, and archiver, and then a standalone archiver, and we'll split those cameras to be able to support the 300 megabits per second throughput, because directory and archiver together have a limit of 100 cameras and 200 megabits per second. Here we have 300 cameras. Also, we need to know the same information, the bandwidth and the network type. And now we're going to assume it's 1 megabit per second throughput. Again, that's 3 megabits per second, 300 megabits per second total throughput. In this scenario, we need 3 servers. And the reason for 3 servers, and this is in the system requirements document, I hadn't pointed this out, but systems above 300 cameras or above require that the directory be on a server by itself. So you'll have 1 server hosting the directory and the media router, and then you'll have 2 standalone archivers and split the cameras between those to support those 300 cameras. So it's a total of 3 servers. And a couple more scenarios. 55 cameras, live video throughput of 1 megabits per second. So that's 55 megabits per second, recording on motion 50% of the time. Recording video throughput is 2 megabits per second. So in this scenario, we have a live stream of 1 megabit per second and a recorded stream of 2 megabits per second. We have 2 users viewing 16 cameras at a time. We're not going to use multicast. We're going to use unicast. How many servers? So we have inbound traffic to the archiver, live stream of 32 megabits per second. So we get that 32 megabits per second because we have 2 users requesting 16 cameras each, plus the recording stream. We have 55 cameras, and the recording stream is 2 megabits per second. So again, in this case, we're using a multi-streaming scenario. The end user has requested one resolution and frame rate for the live stream and a different resolution and frame rate for the recording stream. So we have live stream 32 megabits per second, recording stream 55 cameras times 2 megabits per second is 110 megabits per second. That's 142 megabits per second coming in. And then those 32 megabits per second for the request from the 2 users for live video streams goes back out. So that's 32 megabits per second. There's a total of 174 megabits per second throughput on a server, so we can have 1 server. And licensing for this would be an Omnicast professional package plus the camera connection licenses, because we're professional, because we're over the 50 camera count. Now we have 1,000 cameras, 30 users. In this case, the live and recording is the same stream, so we're not using multi-streaming. We're going to say it's 2 megabits per second recording continuously. All users viewing 30 cameras at a time. Again, we assume multicast. How many servers, how many cameras on each server? So first off the bat, we have over 300 cameras. So we know we have one server dedicated to the directory. Secondly, we have the same stream for viewing and recording. So that's 1,000 cameras at 2 megabits per second coming in, right? Because we're recording 24/7. So that's 2,000 megabits per second coming in. And then we have 30 users, each requesting video streams from 30 cameras. That's 900 streams at 2 megabits per second. It's 1,800 megabits per second. So we have a total in this whole environment of 3,800 megabits per second. And this is a very simplistic calculation, of course. We're going to divide by 300, but you normally wouldn't do that, right? Because you want to leave headroom, but just for ease of calculation, we're going to divide by 3,800 by 300. So that's 13 archive servers, and then one dedicated for the directory for a total of 14 servers. Now let's repeat scenario number 2 with multicast enabled everywhere. So remember, when I said multicast enabled everywhere, that means that the camera can support sending a multicast stream. So because the camera can support sending a multicast stream, the archiver is not redirecting any video. So video is only coming in, it's not going out. The camera's streaming the video that the workstations are requested. So total bandwidth comes from the recording stream, which is 2,000 megabits per second. Again, very simplistic. We're going to use 300 megabits per second as our divisor. So that's 7 servers plus 1 for the standalone directory for a total of 8 servers. Okay. So I hope those scenarios made sense, and that's how we determine the number of servers that are required for an environment. Again, the calculations are very simplistic. You probably wouldn't want to use, or you definitely wouldn't want to use 300 megabits per second throughput. You want to leave some headroom on those off-the-shelf servers that have the specs that only support 300 megabits per second. So next, some final notes. I had already mentioned this before, but the documentation that I've been discussing, in addition to all the documentation for all Genetec products, software downloads, tech support inquiries, etc., can be achieved through the Genetec portal, which is portal.genetec.com. Again, if you don't have access to the portal, you can see on this screenshot where it says registration. You can register for technical assistance. That's for those who are going to be downloading the software or adding tech support cases via the portal. Or you can register as a channel partner, and that will also give you, which everyone on the call I'm assuming is a channel partner, but this will also give you access to our sales tools. So things like the ordering guide and some sales related documentation. The channel partner portal is part of the overall Genetec portal if you register as a channel partner. And this is what when you click on request, this is what it looks like. You just fill that out and somebody from our channel partner team will get back with you. This is a screenshot of the Tech Doc Hub. So once you have access to the portal, you get access to techdocs.genetec.com. And as I said, all documentation for all of our products is accessible here. So administrator guides, user guides, configuration guides, system requirements documents, so on and so forth is all here. Also, a good place for product information is resources.genetec.com. So the resources page has product related videos, additional marketing related documentation. Our blog is at the resources, and some of our partner integration information is on the resources page as well. We have two YouTube channels. So we have our Genetech training YouTube channel. So if you're interested about how to configure a particular aspect of a security center system, whether it's setting up card holders or um, creating users or how to monitor an environment or run a report, we have videos on the Genetech training channel. And on our corporate channel, we have many, many videos related to various products and features of Genetech of Security Center. So that's worth a look as well if you just want a quick snapshot of what some of the products and features are all about. So for contact information, for quoting and orders, that would be channelsales@genetech.com. If you need help with system designs or bills of material in general, you should be contacting your regional sales engineer for that information. But if you're not sure who your regional sales engineer, you can send email to insideSalesEngineering@genetech.com, and they'll direct your email to the right sales engineer for help with system designs and bills of materials and things like that. And of course, for inquiries related to purchase orders or the status of an order, it's customerservice@genetech.com. Also, there's technical support. So in order to call Genetech technical support, the person calling has to have taken our certification classes, Omnicast certification or Synergis or enterprise certification classes. But when you get your certification ID, you're allowed to call our tech support, which is available from 8 a.m. to 8 p.m. There's both a direct dial and a toll-free number. There's no direct email support, but in the portal, as I had mentioned, you can set up tech support cases there. And through the portal, you can communicate with our tech support staff. I thank you for your attendance. That's all of the presentation that I have for today. Ethan, were there any questions that had come up that you felt we should be discussing?
Oh, I think we're good on the question side. Thanks, Howard.
Okay. Well, that's all I have for today. We'll stay on the line for about 10 more minutes. And if anybody has any questions, please enter them in the questions box. If not, I hope you found the information useful and enjoy the rest of your day. Well, it looks like the questions have slowed down quite a bit, so I think we'll end here. Again, thank you all for attending our Designing Omnicast Solutions webinar, and we hope to see you at another Security Center presentation.